Okay, I just wanted to make a video on the homework sets that we do this unit so you don't fall behind and you're not like trying to cram last minute. So this is how to do like the first homework set because all the other homework sets is not open. So this is how to do 4.1 and it's very easy. It's another problem like there's only two different problems. There's two concepts that you need to learn for this homework set. So this is the first concept, and this is finding the radius of convergence. The next one is finding the interval of convergence and then testing endpoints. But for this one, we're just going to focus on finding the radius. And it's really simple. Here are the steps. So first you want to do the ratio test. We know how to do the ratio test. In case you don't, I'm going to do it again. But I want you to know that the ratio test and the geometric series are the same because remember with the geometric series you had 1 plus 2 squared plus 3 cubed. Like this is in the geometric series format, right? And then the ratio between these two is r. And you know that for in a geometric series, in order for it to converge, it has to be less than 1. The ratio test and the geometric series test is like kind of like the same because the ratio test just says what this r is, what the ratio between the points is, and that's exactly what the geometric series use to tell if it converges. So I just want to make sure you know that because that's what makes it make a lot of sense to why it has to be less than 1. So yeah, so we do the ratio test and we set it to be less than 1, which why the reason why I just explained. And then you have to isolate x. So let's just do the problem real quick so I can show you. So first what we do the ratio test. So n plus 1 to the ninth of x to the n plus 1, and then 6 to the n plus 1. We can actually distribute that 9 in, so it becomes n to the ninth, and then 1 to the ninth, which is just 1. So we can just rewrite that whole thing as n to the ninth plus 1 to the ninth, which is just 1. So we don't have to add that. Okay, and then we times it by the reciprocal, because of keep, change, flip, and that just becomes that. Okay, now we just do the ratio test. You know how to do this, so this is just like a refresher for you. Okay, as n ninth plus 1, and then n ninth. If that becomes infinity over infinity, which equals 1, these cancel out. Okay, now we do 6n minus 6n plus 1. These cancel, and you're just left with 6 to the first, which is just 6. So you're left with the 6 over, and then you do the same thing for x. And if this is confusing to you, I'm just doing the ratio test. I think you got this part, so that's why I'm kind of like going fast with it, or like not really explaining myself. But if you need help, then I'll be more than gladly to help you. And so these cancel, you're just left with x to the first, and so you're just left with that. Okay, now we know what the ratio test gives us. Now we need to set the answer to be less than 1. So we need to set this answer less than 1. So let's do that. By setting it less than 1, this is what I mean. I mean, the absolute value of it has to be less than 1, or you could just put that negative 1 there so we don't have to put an absolute value sign. Okay, we set it equal to 1. Now what? Oh, we just isolate x. We need to get x by itself. How do we do that? We multiply by 6 on each side, which gives us negative 6, x, and 6. So the radius of convergence is what? 6. Excuse my sloppy handwriting. Okay, hope that helps.